This is Forlab Plus, a supply chain system deployed nationally in Ethiopia. It covers inventory management, supply planning, forecasting, analytics, and a knowledge base for policy documents, all integrated with an AI assistant that queries facility data directly. The system includes inventory operations designed for health facilities, supply planning with data validation, a four-step forecasting workflow, performance analytics, a national facility map, and document-grounded AI retrieval. It's fully localized, 5 languages. Here's Amharic. Every label, validation message, and tooltip translates. This matters for adoption at the health center level. Back to English. Let me show you how the system works with real facility data. In many countries, health facilities rely on periodic inventory counts to generate supply plans, quarterly in Ethiopia, bi-monthly in others. This consumption data feeds directly into forecasting and procurement. Getting it right at the facility level is where the entire pipeline starts. Forlab Plus has 2 modes. When a facility has an integrated inventory system, the supply plan pulls calculated data automatically: beginning balance, receipts, adjustments, transfers, stockout days, losses. Read-only, derived from actual transactions. For facilities without electronic inventory, which is the majority in many countries, there's manual entry. The pharmacist enters data directly, and this is where AI-powered validation becomes critical. Normal entries: beginning balance, quantities received. Now I'm entering 50,000 units. This facility's historical average is around 5,000. The system flags it immediately. An AI validation layer compared this entry against the facility's historical consumption pattern and identified a 10x deviation. This is the type of error that, aggregated across thousands of facilities, distorts national procurement. The validation catches it at the point of entry. Correct the value, the flag clears. Each cycle, the pharmacist gets feedback on what reasonable numbers look like. The data quality improves over time.
Forecasting. 4 steps. Step 1. Define the scope. Time range, facility, program, product category. The system includes contextual guidance throughout. Users can learn concepts like demand forecasting as they work. Load data. Step 2. The system displays 8 quarters of historical consumption per product. The color coding is important. Yellow means the AI detected a stockout period and adjusted consumption upward to estimate actual demand. Red flags 0 consumption during a confirmed stockout. The raw number would understate real demand. Data quality check. The AI evaluates each product's data and assigns a readiness status. Green, ready. Yellow, gaps that may affect reliability. Red, insufficient for a defensible forecast. This prevents forecasting on bad data. Step 3. Generate. The model is Profit, handling trend, seasonality, and change points independently for each product. The output: products forecasted, annual total, year-over-year change, and detected patterns. Each product shows quarterly values, trend direction, seasonality, and confidence. The detail view: quarter-by-quarter comparison against last year, seasonal patterns. A facility seeing consistent Q4 spikes can plan procurement around that pattern. Step 4. Review and save. The system compares past forecasts against actual consumption using WAPE and MAPE. This is the feedback loop. Each cycle, the facility sees whether forecasts are converging with reality. Save. Past forecasts are accessible for historical comparison.
The AI assistant. This is where the system's analytical capabilities are accessible through conversation. The system is model agnostic. Facilities can run on Google Gemini, OpenAI, Anthropic Claude, or locally hosted models through Ollama. A facility with limited connectivity can run inference locally. First query: stock monitoring. Which products are below 2 months of supply? The AI agent calls Get Stock Status. It queries this facility's inventory, pulls consumption data, and calculates months of stock. The result is a structured table with stock on hand, AAMC, months of stock, and a status classification: critical or low. It then provides key takeaways: 3 products below the threshold, paracetamol at 0.5 months requiring urgent resupply. This query replaces manual spreadsheet cross-referencing. The tool panel shows exactly what ran: tool name, parameters, data source. full transparency. Second query, consumption analysis. Show me 3 years of paracetamol consumption trend. The agent returns 2 tables, quarterly consumption by fiscal year and stockout days per quarter. Annual consumption grew from 18,400 to 20,700, a 12.5% increase. It also surfaces key observations. The AAMC has risen from about 1443 to 1867, and the latest quarter shows 6 stockout days, consistent with the critical stock level we saw earlier. The stockout days column tells you how reliable each year's consumption figure is. Third query, forecasting through conversation. Generate a forecast for amoxicillin 500 milligrams. The agent calls the same profit model used in the forecasting wizard. The result? An annual forecast summary showing 10,443 capsules. Increasing trend, high confidence. The quarterly breakdown reveals this is a highly seasonal product. Virtually all demand is concentrated in Q4, with a seasonality index of plus 5.12. The system then generates a resupply recommendation. Given current stock of 570 against forecasted demand of 10,443, it calculates an order quantity of approximately 9,873 capsules. The same analytical engine, accessible through a question. The knowledge base. Policy documents, quantification manuals, and SOPs are uploaded and chunked into semantic embeddings, searchable by meaning. This facility has 3 documents loaded. I'll ask a question about forecasting methodology. What methods does the quantification manual recommend? The AI searches across document segments and generates a structured response with source citations, document title, section, and page number for each claim. It identifies 4 forecasting methods from the manual: consumption-based, morbidity-based, demographic, and service statistics, each with a verifiable reference. A 200-page quantification manual becomes something any supply officer can query and get a sourced, verifiable response. Thank you for taking the time to watch this demo. Many countries still rely on periodic physical inventory counts as the basis for forecasting, or depend on national-level assumption-based forecasts that don't reflect what's happening at the facility. Forlab Plus is an opportunity to build national-level forecasting from the ground up, using facility-level consumption data, with AI validating and improving data quality at each reporting cycle. Please reach out to us for any further inquiry. We'd welcome the conversation.